Hello everyone. So today we'll be solving the problem number 7, 8 subsets, right? So uh, let's see what the question states here. We are given an array nums, right? So containing unique integers. See here, we are given an array nums containing unique integers. We must generate all the possible subsets here, the power set, right, of these numbers. We have to generate all the possible subsets, nothing but the power set of these numbers. So the output can be of any order, but we have to make sure that no duplicate subsets should exist here, the simple one, right? So again, we are given an array nums containing unique integers here. We must generate all the possible subsets, the power set of these numbers, right? So the output can be in any order, but no duplicate subset should exist, right? So here see, we have 1 2 3. Empty subset is always a subset, right? So yeah, empty integer within the array is always a subset of something given for the given subset, right? So we have to consider this one at any cost. So 1 2 3, 1 2 1 2 1 3 2 3 and 1 2 3. These are the subsets basically, right? So first we can directly consider 1 2 3 and the empty one 4, right? So it can be of any order, it doesn't matter. So here empty 1 2 3 we have already considered. Next we can go with the 1 2. Next we can go with the 1 3, then 2 3, that is also 1. These three, right? So here 1 2, this one I'm speaking of 1 2 1 3 2 3 and then finally 1 2 3. That is also the subset, right? So main one 1 2 3. Same goes with the second one here. So here 0 empty subset, we have to consider empty one, and the element considering the element 0, only one element we have within the array, right? So this is also the subset 2, right? I hope the question is completely clear, man. They have given us wonderful examples just for the sake of understanding here. So let's discuss the approach followed by the complexities and then let's write the code, right? So just give me a second here. Yeah, so first thing here, we have to start with a some empty subset. So I'll consider this example 1 2 3 itself, right? So first thing I want to mention here is we will be going with a backtracking. So what we'll be doing here, we will be going with a backtracking approach, right? Backtracking, nothing but the recursion, mainly recursive backtracking, right? Backtracking uses the recursion itself, right? So we'll be going with a backtracking. So we will start with the empty subset here. When I say empty subset, this one, we always have to include the empty subset, right? So we'll start with a empty subset. At each position, we have two choices. Either we have to include the current element or we have to skip the current element, right? So we will be recursively exploring both choices, and we reach the when we reach the end, we will record the current subset. Let's see the same thing for the first one, right? First example. So first we have went with the empty subset, nothing but the start. So we will include one. Now we will include one. So this will be empty subset along with the one, right? So this is fine. Now we will include two. Now we will include two. So we empty is done, one is done. Now we will include two, the next step, right? So now we will include two. So this is fine as well. So we have what we have now, 1 comma 2. Basically after including 2 we have 1 comma 2. This is fine. Now we will what we'll do, we will include 3. The next number we have here is 3. We will include 3. Now this subset becomes 1 2 3, 1 2 3, right? So now we have empty 1 along with 1 2 and 1 2 3, right? So the next step would be we will be skipping 1 3. So we will be skipping 3, the last element that we have added, right? So now this becomes skipping 3 becomes 1 2. Skipping 3 becomes 1 2 here, right? So this one, this is fine. Skipping 1 3 becomes basically 3, right? So 1 2, basically skipping 3 becomes 1 2. This is fine. Now we will skip 2. Now we will skip 2, nothing but it becomes 1. This becomes 1, right? So now after that one we will be including 3. So this becomes 1 3. After skipping 2, this becomes 1. After that one we will be adding 3. This becomes 1 3. Again we will skip 3. This will lead to 1. This will lead to 1, right? So this is fine. uh, Now let's come to the skipping of one part. So skipping, now we have 1. When we skip 1, we will get the empty, and we will include 3, then it becomes 2 comma 3. This becomes 2 comma 3, and finally we will skip 3. We will skip 3. This becomes 2. This becomes 2. Right, so this is fine. Now what we will do, we will skip 2. We have only 2. We are left with the last step. We will skip 2. When we skip 2, sorry, this will be empty. Empty, right? So then we will include 3. This becomes 3. This becomes 3. Right? So this is fine. Finally, we will skip 3 as well. This will be empty. This will be empty. So we are done with all the steps, right? So the output that we need to return from this one is empty. 1, 2, this one 2, 1, we got the last step 1 here, we got last step 2, and we got the empty first itself. Empty 1, empty 1, this one will be considering, 2 we will be considering, and 3 we will be considering, right? And we will be going with 1 2, this one 1 2 3, right? 1 2 and 1 2 3, 1 2 1 3, and also 2 1 somewhere. I missed 2 1 somewhere actually. Yeah, this one will be considering in the form of 2 1 also we have to consider, man. 2 1 we don't have to, right? 1 2 we have considered, so 2 1 we don't have to. We need to consider 1 3 we have considered, 1 2 also we have considered here, 2 3 also we have considered, right? So this is fine. Just 1 second. While skipping 1, mm, we are skipping 3 while we have included, this becomes actually 2 3, man, not 2 1 actually, this part. So this one we are considering 2 3 as well. So now we have the same thing, empty 1, this one 2 3, 1 2 1 3, as well as 2 3, along with 1 2 3, along with 1 2 3, this one, this part as well. So the output that we got here is, so if I summarize the same thing, if I group everything into one array, we have got the same output as the output they have mentioned in the example one, right? So the approach works absolutely correct. So this is simple backtracking, man, right? So this is simple backtracking. So this will be the approach we'll be going with. This will be the approach that we'll be going with basically, right? So as we are completely familiar with the approach, let's do one thing. Let's discuss the complexities very quickly. So here the overall time complexity would be big O of n into 2 to the power of n. Big O of n into 2 to the power of n, because we are generating 2 to the power of n subsets and we are copying each subset that takes up to n times, right? So this will be the time complexity would be big of n into 2n. And what would be the space complexity here? The space complexity would be big of n, because we will be going with our we will be making use of the extra space for the recursion stack, right? Recursion stack depth can go up to big of n. We know this one, excluding the output storage I'm speaking of here, right? So this will be big of n will be overall space complexity. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n into 2 to the power of n and big of n respectively, right? So yeah, so this is the time complexity and the space complexity for the code that we have written basically, right? So this is fine. Now let's do one thing. We are done with the time complexity and the space complexity, along with the approach as well, right? Now as we are completely familiar with the approach and the this one complexities, we are good to write the code. Let's start writing the code, right? First step here would be we have to create the final result list to store all the subsets. So we'll be going with a list. This will be list within the list. So just give me a second here. List within the list. This one will be integer. This one will be result equals new array list. So this is fine as well. So let's start the backtracking from index 0 to with an index 0 with an empty subset. Means I'll just go with a backtrack here. So before going with the backtrack method, we have to go with a helper method backtrack. We have to write the backtrack method first, right? Or the backtrack function. So I'll just go with a private void backtrack here with the parameters. I need nums, nothing but the array. So here I need start. Hmm, I need here list. This is also fine. Integer. And one more thing. So this has to be capital I. This is fine. Now and list of list. This is also fine. This one will be integer. Let me close this one as well. So this will be a result, right? So this is also fine, man. Within the backtrack method, so let's add the current subset. Nothing but let's make the new copy. Yeah, let's make a new copy to the result, man. So I'll just go with the result dot add. This one will be new array list. This one will be current. So this is fine. Now we have to loop through the remaining elements, that is starting from the start. So this is one of the important things, right? So this will be int I equals start. So this is fine. So I less than nums dot length here. Let me increment I. So this is fine. Next, let me include the nums of I in the current subset. We have to, right? So I'll just go with the current. So here we haven't, for the current we have considered CORR, right? So within the parameters, this one, yeah, current dot add. This one will be iterated value of the nums. So now let's recurse for the next index, nothing but recursion, right? So I'll go with the backtrack method here. This will be nums, comma I plus 1. This is also fine. This will be current, comma result, and comma result. So we are just recursing for the next index here. Next one would be, we have to backtrack, means we have to remove the last element. This would be current dot remove. This one will be current dot size minus 1. This is fine. Yep. Let me format the code once, man. Yeah, we are done with the, we are almost done with the code. So we are done with the this one helper method backtrack. So we have to perform, or we have to start the backtracking from the index 0 with an empty subset, right? Initially we have to start with the empty subset itself. We have to start the backtracking from the first index, or this is 0 based indexing. So we have to start the backtracking from the index 0 with an empty subset. So let me copy this one. Let me give here backtrack. So this one will be nums, comma 0, comma new array list. So this is fine. Comma result. This is also fine. Finally, let's return the result. Nothing but we have to return the final result list. So this will be return result. So yeah, this is it for the code. Let me hit the run button here. I hope this works, man. This is simple one actually. We have the compiler, so this has to be current dot size. Mm, remove current of size minus 1. Line number 14. Where is line number 14? The last one. Yeah, let me run the code again here. So yeah, now you can clearly see here the sample test cases are getting passed. Let me hit the submit button quickly. So yeah, I hope this, yeah, I was about to say, I hope all the test cases get passed. This is fine. All the test cases are getting passed, means the code, whatever the code that we have written works absolutely correct for all the test cases, right? So now we are done with the coding part, means I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.